Okay, the day that we started graphing with Desmos, we had equation for circle, then we had equation of the ellipse next. And I've just lined those up on top of each other so that you can compare them. Because they are related. Both of them have x minus h squared, y minus k squared. They both have a plus sign in between. So the differences would be that the ellipse equals 1, where the circle equals r squared. But I can actually make the circle equal 1 if I wanted to. No matter what r squared is, I could make it say equals 1. What would I do to change r squared, pretend r squared is like 25? What would I do to make this say equals 1? It's an equation. What could I do? Do what, Joe? Well, if I subtract it, it'll say equals 0. So what could I do instead to make it say equals 1? Well, then I'd have to do both sides to the 0 power, so we'd have 1 equals 1, and that's not helping. But you're thinking, you're making it too hard. If you divide by that number, 25 divided by 25, or r squared divided by r squared, it's going to equal 1. So I've done that. It's right up here. So now I have the ellipse equation and the circle equation where both equal 1. How are they different?
They're in the division.
Both of them?
Yeah.
How are they different? Okay, so say that again, Savannah.
Like those two are just numbers, but that's the radius squared.
Okay. Yes, this is radius squared, and this is also radius squared. Here, we know it's not a radius because you guys saw the ellipses. You don't have a radius because it's longer one way than the other. But these numbers here, what makes them not the radius? When you first started doing it, you can maybe even see under here, when you first started doing it and you typed it all in, a lot of you were like, that's a circle again, and then you wrote down circle, but then you went and actually did what I told you to do before you could tell it was an ellipse. What did you have to do to the A and B so it wasn't a circle anymore? Well, you had to change, they couldn't be the same number. So if these are the same number, they're going to be a radius. You're going to go the same direction, or the same length in each direction. If they're different numbers, they're going to go different amounts in each direction, making it elongated in one direction. So the only difference between these two equations is these two numbers are different. These are the same. So we're going to do ellipses today. And before we do that, one more thing with the circle. If you like need a circle in a bind, and you have some push pins and some string and a pencil around, how would you make a circle? What would you do? What would you do? Wait, what's this? How does a push pin look like? I can't draw it! There you go. There's my pin. So, you attach that to the string. And then what? This, I don't know what I was thinking when I decided to draw this. Here's your pencil. There's your pencil. And then what? You just go all the way around. Woo! And you draw a circle. If you use it correctly, I made my string too long. If you use it correctly, oh my gosh, this thing is so touchy today. Use it correctly, it'll draw a nice circle for you. Alright, how do you make an ellipse with push pins, a pencil, and string? This one's, I don't have to draw. Push pin, string. Look. So you just need 2 push pins, string, pencil, and you can make an ellipse. We're gonna hand, like, sketch them. We're not gonna actually accurately draw them, but we are gonna find the push pins. So the push pins are something we're going to learn about today. So with the ellipse, you have, with the Desmos activity, I just took a screenshot of it. With the Desmos activity, you should have already learned how to find these lengths from the very center to the very ends. And then you should have already learned how to find these lengths from the center to the ends when you did the Desmos activity. And hopefully you have it written in your notes, because like I said, that was going to be your notes, so you're going to keep using. What we're going to do today is we're going to graph it, and then we're also going to find these push pins, which we're going to call foci. It's written on your paper, you'll see it. Foci or foci, you can say it either way. And this string, which we're not going to do a whole lot with, they normally call it like a D1 and a D2, distance 1 and distance 2. But if I add together D1 plus D2, I get the length of the string, which no matter where I go, I could put a point here, and D1 and D2 are going to be the length of the string. Or I could put a point here, and D1 and D2 are going to be the length of the string. And actually, D1 plus D2 is the length of twice this major axis, which we're going to learn about also. But the D1 and D2 we're not going to do much with. That would just be higher level stuff that you do. We're going to find the foci and we're going to graph it. Okay? So all this is information about how to do it. And they talk about A squareds and B squareds, but I was telling you guys as you were asking me questions, don't focus on the A and the B. Focus on which number is bigger and where it's located. If the bigger number is under X, it's going to stretch horizontally like this. If the bigger number is under X, then horizontally it's going to be bigger. If the bigger number is under Y, then vertically it's going to be bigger. So the bigger number is under X or the bigger number is under Y, that's what the shape's going to look like. HK is always the center. We have something called a major axis and a minor axis. And those would be, if I drew through the endpoints, we'll have 2 axes. The major one is the longer one. The minor one is the shorter one. To find that, if you know half of it, which you will know half of it to graph it, you just have to double that amount. That's what it's saying all here. The only thing you really need to pay attention to on this first section of notes is how to find the foci. To find the foci, you take the A squared and the B squared values, which are underneath the H and K, underneath the X and Y. Take those 2 values and you subtract them. When we subtract them, it needs to be positive answers, so you always do the big one minus the small one. And then you square root it. When you square root that, then you'll get your C value, which gives you the location for the foci. And the foci are always on the major axis. Always on the major axis. So if I drew this graph, would my foci be horizontal or vertical from the center? They'd be vertical. I don't know where they'd be. Maybe here and here. I have no idea. But they would be vertical. And they would be on the inside. It's contained on the inside. Okay, so example 1, we're going to go through the following. We're going to take the equation. We're going to make it say equals 1, so it is in that graphing form. So I have to divide everything by 9. So I have the equation x squared over 9 plus y squared equals 1. So they start talking about A squareds and B squareds. I'm going to talk about that just being big numbers and small numbers. I'm going to look up here, And I look what's under x squared, and I look what's under y squared. What is under y squared? Okay, if you need to write it there. When I look up there, which one's bigger, 9 or 1? 9. So we will square root both of those. We will square root both of these to find length. We will need to square root them. Oh, where's our center? I didn't write it yet. Where's our center? 0, 0. Grab that. How do I know the center? It's HK, just like it was for circles. Okay, so it's like just like doing the circle, only this time we're like not going the same distance from the center, we're going different distances. So the distance from the center x-wise is 3. So from the center, since it's under x, we go 3, negative or positive 3 from the center, because that's under the x. Under the y is 1, plus or minus 1. So vertically, we go up or down 1. So it's just like the radius was, only this time they're different amounts. So once you've gone out 3, negative 3, you've gone up and down 1, you have your ellipse. So we have to write down the major vertices, the minor vertices, then we'll find the foci and we'll graph them. So the major vertices and the minor vertices, you can find them from the graph. I just graphed them. Or you can also use the information here. So I'm going to use the information, but they should line up with the graph. So my major vertices, since it is, the 3 is the bigger number, it's under the x squared. I'm going to take my center and I'm going to add or subtract 3 to the x value. We'll get 3, 0, and we'll get negative 3, 0 for our 2 vertices. The y has plus minus 1 under it, so I'm going to change only the y value for the minor vertices, so I'll still have 0 here, 1, and then 0 here, negative 1. And then I can look at my graph, and yes, those are the points I plotted. I even correlated the numbers, with color. Finally, you have to find the foci, and the foci says if you take the square root of the big number minus the small number, and we're talking about the a squared and the b squared before it is square rooted up here. So we're talking about 9 minus 1, the two bottoms, the two denominators. And if it does simplify, I expect you do simplify it. So 2 radical 2. You need help with simplifying? Come see me, I'll help you out. Which way do I plot my foci? Horizontally or vertically? Why? Because it's the longer side. So it's the one that's longer, it's the major. To write the points, since it's horizontal, we're going to add it or subtract it to the x of the center. So I'll have 2 radical 2, 0, and I'll have negative 2 radical 2, 0. But to graph it, I might have to know what the decimal is. 2.8-ish. So you're going to graph as accurately as you can. The most accurate part would be what's written on the blanks. I'm going to use visualize it over here, but what's written on the blank, the 2 radical 2, is not a decimal. It's the accurate, exact answer. So I want to see the decimal on the blank over there. I did it as a radical. Good. Next one. Next one, page. It didn't seem too bad, did it? So the next one is already in the standard graphing form. We need to find our center. Where is our center? HK. 1, negative 3. Perfect. Then to do the major and minor axes, I'm going to square root the 25 and the 36, and I'm going to say, which one's bigger? You need to slow down because you're close. 6 is bigger. So I'm going to add and subtract 6 to which the y's, because it's under the y, from the center. So I'm going to have 1, 3 and 1, negative 3, or negative 9. Just kidding. Negative 9. There we go. You could go over to your graph and just add 6 up and down. You don't have to find the answer without the graph. You can use the graph if you like. Do you see what you did wrong? Okay. See, and I want to point that out because people will still do that on the quiz and test. Make sure you go from the center. Okay, and then the minor vertices, I'm going to do the same thing, only this time it's under the x. So I'll be changing the x value. So we'll have 6, negative 3, and negative 4, negative 3. While you're graphing this, if something just doesn't look right, maybe you've made a mistake. It's possible to make a silly mistake. Probably already made like 10 of them today. We're going to find our foci by finding the c value. To find the c value, you're going to subtract the denominators, big minus small, and then square root it. We get square root of 11, and then I say which way is major, which way is longer, that's the y. So I'm going to add or subtract the square root 11 to the y center. To graph it, I'm just going to find out what square root 11 is. 3 point something. 3.3. And go up and down 3.3. From the center. And then you have your completed graph. Is this the standard graphing tool? It is not. So now we have to complete this square. So there was 2 of them in your circle homework last night that were similar to this. They were a little bit easier than this one. I'm going to go through the steps. First step we want to do is get rid of 84, move it over, and kind of rearrange. Leave some boxes in there, leave some squares. We've got 16x squared plus 96x plus squared plus 4y squared minus 8y plus different square equals negative 84 plus square plus different square. So to factor out the 16 now. So to factor out the 16, but the 16 is only being factored out of the x values. So I will have 16, and then I'll have parentheses, x squared plus 6x plus fluffy cloud. Okay. For the y's, I'm going to factor out a 4, but only from the y's. So I'll have left over y squared minus 2y plus fluffy cloud. So I'm going to complete those fluffy clouds. So to complete the fluffy cloud, you use what's inside. To use the b over 2 squared trick, you have to get that x squared 1. That's the only time the b over 2 squared trick works. It would not work up here. So that's why I factored that out. Now I can do 6 over 2 squared, 9. But then I have to multiply it by 16 to put 144 over here. The only reason the b over 2 trick works is because you took out the 4. So don't use that 8 to do it. Use after you took out the 4. Negative 2 divided by 2 squared is 1. Multiply by 4 is 4.
Yeah.
Question? Then I'm going to factor, so I'll have 16 parentheses x plus 3 squared plus 4 parentheses y minus 1 squared equals, add all that up, 64, is it? I can't remember. I'll look. Somebody's in a hurry to find out for me. Yes. What I want to do is I want to get this to say equals 1. I'm going to look over here, and I'm going to divide everything by 64 at the same time. Divide all terms by 64. Hopefully, if you've been given a nice problem, these will reduce. You've been given a nice problem. They don't have to. But. So I have over 4, and then I have y minus 1 squared over 16 equals 1. So it is in the form when you have it equal to 1. Yes.
How do we get 64?
The 64 over before dividing?
Like, I didn't miss over.
It was negative 4 plus 144 plus 4. Is it because I missed the box?
I don't know. Oh, yeah, gotcha. I thought
My
it was
boss is
44. Yeah.
Trying to make it fit a little bit better. There we go. But also, don't just think it's 44. How did I get 144? Because that's the part that you're going to be doing on your own. How did I get 144? That's where you have to know. 16 times 9. So I know it's not 44. Okay, now we can complete the information. I'm going to go fast. If you need to watch this video 60 million times, right, you can. Because it will be available to you. So our center is at negative 3, 1. Then I'm looking at the two numbers, and I'm going to square root these two numbers. This one's going to be plus minus 4. This one's going to be plus minus 2. Which one's bigger? The y values. So my major vertices, plus minus 4, go to the y's. Well, it's always going to go to the y's, but that will be our major. So our majors are going to be negative 3, comma 5, negative 3, comma negative 3. Our minor vertices, we're going to add subtract 2 to the x's. It's negative 1, 1, and negative 5, 1. And then for the foci, we take from the original denominators, big minus small. So 16 minus 4. Square root that, simplify it. And that is added to the y values because that's the major. So negative 3, 1 plus 2 radical 3. And negative 3, comma 1 minus 2 radical 3. I kind of ran out of space there. So to graph it, I need to know what 2 radical 3 is. It's approximately 3.5. As soon as you have that, go ahead and turn the page and start doing the next one. I'll catch up. And then you're going to do the 2 radical 3, plus or minus 2 radical 3, vertically from the center. So I found this is approximately 3.5. So if I were to move over here, it would go. So it would go from the center down 3.5, from the center up 3.5. So you can see that the x value is -30 and down. Yeah, I know that. I mean, I don't know what decimal it is, but. So I wanted you to try to start it on your own because it's one of those complete the square kinds. And if you don't know how to do it on your own, you aren't going to be able to do most of your homework. But start it on your own, see what help you need. See what you're not understanding. I will jump up there and catch up to you. So you should be doing this on your own and then checking in with my answers. If you're straight up just writing step by step, you're not going to know if you understand it. You're not going to be able to answer your questions because you don't even know if you have it. If you're ahead of me, even better. But you got to make sure your equation's right. If your equation was wrong, you're going to be wrong. This is not. If they were the same, if that were to happen, then you would say, oh, I'm so. But that's not going to happen today. Eventually, they're all. Yeah. That'll be like the fifth section. We got circles and ellipses, then hyperbolas, then parabolas, then all things. I'm going to figure it out. No, because you're going to keep doing it. And the first three are really similar. Parabolas are.
And that's not going to be, is this going to be on the exam?
Up through ellipses could be on the exam. But it won't be much, because we don't even have a quiz on it yet. Maybe like complete the square might be on there, or, you know, rewrite an equation, but it's not going to be much. The exam's mainly going to be chapter, or the real life trig chapter, which is kind of mixed up chapters, and then chapter 9. Don't worry, I'm giving us an extra study day in class. Well, I wouldn't say don't worry. Some of us do need to worry, but those of us that haven't been failing our tests, don't worry. Those of us that have, we're going to need that time. Major vertices, what do we got? We got plus minus 5 to the y. I do have the second test graded. It is all graded. It's stay on my desk. As soon as I'm done with these, I'll upload, you know, put them in Hack so you can see how you did on it. Well, I won't have time to hand them back today, but maybe, yeah, I'll do it tomorrow. I got distracted. I hope I graphed this or written those correctly. Skinny little one. Square root 25 minus 1 is square root 24, so 2 radical 6. And that's going to be vertical, so we'll have 2, comma 1 plus 2 radical 6. And 2, comma 1 minus 2 radical 6. And to graph it, I got to find what 2 radical 6 is. I feel like somebody was yelling out the answer, but not loud enough for me to hear. 4.9. So you'll have it here, and then there. Is that you? All right, last section. Last section, we're not going to have time to do every single one of these, but I can do them and upload the rest of them on Canvas if you come across one that's similar to this and you want to go look at the answers. So I don't have graphs for you, but me personally, I feel like it's easier to visualize if I have graphs. So I've got some graph paper if you'd like to use it, either now or in your homework for these. I'm just going to pass it out right now. But what we're going to do is we're going to attempt to find the equation. We're going to find the equation of an ellipse that has this information. So the first thing that I see is the foci at 5, 4, and negative 3, 4. So maybe graph those right away. And then there is a major axis that is 10 units long. Well, that is for homework. I think we'll start with those two.
Is it one per person?
The strip of 6 that I just handed out? Yeah. Okay, so the foci at 5, 4 and negative 3, 4. As soon as I see that, I can now find some information. What do you think we could find? The center. Now, without seeing it, to find the center is just the midpoint formula. It's right in between those. So you could use the midpoint formula. You could look on the graph and count. Remember the midpoint just averaging? Both of the y's are 4, so the y value of the center is going to be 4. You just have to find the x value, which is 1. And then you look at your graph and you're like, yep, that's right in between. That looks right. There's another piece of information they give us. They give us that the major axis is 10 units long. Where do I know, how do I know where to put the major axis? The foci is on the same, is in the same direction as the major axis. The major axis has to be centered, so it can't start here and go 10 units this way. It's 10 units total. So how much in each direction? 5. The foci are 4 in each direction. So I can start writing the equation. The equation is going to be my center, x minus 1 squared plus y minus 4 squared equals 1. I know that. I also know it's going to be over some values that I can find. The major axis is horizontal. Each direction is 5. So I can say underneath the x's is going to be that number that gives me 5 in each direction, which is what number? 25. Remember, it's like a squared, so you have to take that 5 and square it. So we just have to find what's under the y, but we don't know anything about how big that is. So you're going to use your foci equation, and you're going to plug in, the bigger one is 25, because that's the major. We don't know what's under the y squared, but we can find the c squared. The c by itself is 4, so this would be 16 over here. So 25, take away what number is 16? Other way, 9. 25, take away what number is 16? 9. 25, take away 9 is 16. We're using our foci equation to find the missing number.
Do you have the square?
Well, the square root would give us these. So if I needed to graph it, I would need to know that. But in the equation, it's squared. So I could square root it and then square it again. Same answer. 9. Yeah.
Can you explain again how you got this 25?
Yeah. So did you understand? Okay, so the major axis was 10, so it goes 5 in each direction. So that's kind of like our A value, but I was not really stressing the A versus B. Okay, but that's like when you go to graph it, you square root this number and you do plus or minus whatever that number is to graph it. So I kind of went backwards. I knew I go 5, so I just square it to go underneath here. Okay? So after doing these graphs, the first like 6 questions or whatever, after doing the graphs, hopefully this stuff will make a little bit more sense when you go to do it in the homework. And of course, come with questions. Come see me if you have any. I could do more of these, but they're all similar. They're all kind of the same. But I will fill them in. I'll fill them in before I post the notes on Canvas if you want to write down any more examples. Let me stop the video.